Hello and welcome everyone to another month of the Austin Python meeting. It's April and we are welcome today with Dr. Shen with his presentation on federated learning made simple with Flower AI. Thank you for coming. Thank you all for coming. And I'll just hand it off to you and you can take it away.
All right. Thanks, George. Hey, everyone. I'm super excited to be here. So my name is Chong Shen. I'm a research engineer at Flower Labs. So I'm also one of the core dev teams as well on the Flower platform itself. So yeah, let me give you a sort of a short talk about federated learning in a simple, hopefully digestible way. And I'll give you a couple of examples of how you could get started using Flower to build a federated learning app for any of the use cases. Okay, so feel free to stop me anytime and ask me any questions. If my audio cuts out as well, so please let me know. And I also have to excuse I might have a cough. I'm a little bit under the weather, but I should be doing fine. All right, just let me know. Cool. I'll start off by asking the question: why federated AI? What's the motivation behind this? Well, we know that the data around the globe is naturally decentralized, and AI can't use most of it just because of this decentralized manner of the data. If you try to collect the data, it doesn't quite solve the problem, right? Because there's a lot of cost and challenges surrounding this. So one of the options to try and solve this is to use what is called the federated AI approach, where the compute itself is pushed to the location of the data source. Right, I'll dive into that a little bit more. Okay. So given this overview, the takeaway here is that with centralized AI, right, you have a mode where, let's just say you have a lot of devices generating data, and you want to centralize them into a server, and you try and train them. Unfortunately, centralized AI can't access most of the data, right, because you need to move the data, and that creates some challenges, especially across geopolitical borders and whatnot. With federated AI, instead of moving the data to the compute, you move the computation to the source of the data. In that way, the data stays where it originates, and there's a lot of benefits in terms of offloading the compute to the data source itself. Okay, so hopefully that gives you a very quick flavor of the motivation of what federated learning can do for you. Let's dive a little bit deeper into how does federated learning actually work. Right, I'll show you a little bit of math, but it's just as a quick a flavor. It's nothing too fancy about it. Okay, let's take a look. Right, so there are a couple of steps, 5 in total. The step 0 to do federated learning is you want to initialize a global model. Right, let's take this scenario. Let's just say you have a couple of devices here that's generating data. It doesn't have to be devices. It can be organizations as well. It can be, for example, a hospital or a financial institution, etc. That stores some sort of siloed data. Okay. There is a central server that handles the coordinations of this a model, which I will talk a bit more in later on. So let's just say step 0 is to initialize the global model, right? You have the data sources, D1 to D5, but it's 5 each devices. And you initialize the global model weights, say W, right? Just weights. Okay. What you want to do is you send the model W, right, to all the connected organizations or devices, right? So just the same W from the server gets sent across. With this model W and each of the local data, D1 to D5, you train the model on the local data on each organization or device. In this step, all of these devices will have their own model weights, local model weights, yeah, W1 to W5, right? So this training, this equation just simply says you do like a forwards and backwards pass of your neural network training, for example, and then you get the updated model weights W1, right? After you have trained the model weights on each of these devices then send these models, their respective models, back to the central server. And then finally, the last step is when you have all of these different models from the different devices, you aggregate them. In the simplest sense, or the simplest way to aggregate them is just to take the average of all the model weights and divide it by the number of clients that participate in the round of training, right? For those of you who have somewhat familiar with federated learning, the most classical way, the most classical strategy to aggregate this is the federated averaging approach, right? In any case, there are many ways of aggregating updates into the new global model. So that's the gist of one round of federated learning. The next part after this is simply to repeat steps 1 to 4. And you continue, you basically have many rounds of federated learning until the global model converges, right, to the level or to the performance that you want or the loss that you want. And once you're sort of happy with the model performance, then you can move that over to deploying it. Okay. So that's the sort of the gist of how federated learning will work. There are other variants of federated AI, right? The next one is what we call federated evaluation. So in this case, what you would do is you'd send a trained model, so it's already pre-trained, you know something. You send it to all of the sources of the data, right? So the server will take the model and then sends it across all of the data sources. Then each device or organization would evaluate the model against its own local data, produce a statistics or a metrics, and send them back to the central server. The central server then aggregates this metrics and then gives it back to the user so that the user can analyze and understand what is the aggregated model performance across all of the clients that participate in the federated learning itself. Right. So this is one another way of using the federated evaluation. One other approach is what we call federated analytics. So in this case, you are trying to, let's just say in a simple sense, do a query against the database. So a user will write a piece of code that gets sent to the server, and the server then sends this code to all the clients, and it computes some statistics on each of these data sources. The statistics then get sent back to the server, and same like before, it gets aggregated, and then the user can analyze and determine what's the distribution, for example, aggregated across all of the clients. Okay, hopefully that gives you a sort of a good understanding, or at least a general understanding of the flow of federated learning and how what you can do with it. Okay. So now let's take a look at how does Flower come into the picture, right? What is it about? So Flower platform is a unified approach to federated learning, analytics, and evaluation. We provide a set of tools for you to build the apps that you need to produce a federated learning solution. With Flower, there are lots of techniques that you can apply and use it on. For example, large language models, neural nets, and all your linear regression, all the way to pre-training and fine-tuning, foundational models. All of this is possible with Flower, and there are a lot of research papers written about this, as well as GitHub examples as well. So if you're curious about some of these, just let me know. I can point you to them. Our ecosystem is also incredibly rich. The core of Flower is open source, so you can take it and use it. It's written in Python, and we also are machine learning framework agnostic, right? Which means you can use PyTorch, TensorFlow, or the more exotic ones like JAX, if you like. We also work with companies like NVIDIA and Intel, and they build some of their tooling for federated learning also based on Flower as well. So a very rich ecosystem. In terms of our AI developers, the people who contribute to Flower as well, we find that AI devs actually love Flower. We have a lot of active involvement from around the world, 5,700 developers, and 5,700 stars. I counted this. I looked at this number actually just earlier today. We also have 2,000 dependent GitHub projects on Flower, which is pretty impressive itself. And to date, we have 150 plus contributors to our open source repo. We hold, every year we'll have the Flower AI Summit. So we just ran this about 3.5 weeks ago. So there's the pictures from the event. We invited researchers and also people in the industry to give the talks. So we have a holistic perspective of the bleeding edge work for federated learning, as well as I guess the lessons in the trenches. We try to apply federated learning in industry, what lessons learned, and what you can share. We also had some very interesting special guests as well, which is pretty cool. You can see over here. In addition to the summit, we were for our community engagement, we have a Slack channel. So if you want to jump on Slack and ask us anything about federated learning, feel free to you can scan this QR code and join us on Slack, ask any questions. We also actively answer questions on Flower Discuss. That's our forum where we just keep track of all the questions. I think it's more searchable as well. So Flower Discuss is a very good way to ask your questions, and we can point you to more relevant resources over there. Right. Based on the Flower framework, there are a lot of researchers that publish their work also in many conferences. We also attend these conferences as well, like NearIP, Cyclear, and a few other conferences. And one of the nice initiatives that we have been pursuing for a long time is to establish the Flower baselines. Right? So Flower baselines is a collection of reproduced baselines. So we took a number of papers, well-established papers, and we work together with contributors as well. So the contributors will try to build the baseline to reproduce the results in those papers, right, with Flower. So we keep track of them and make sure they are reproducible. And that way, we can provide a stepping stone for other contributors as well as other researchers to build on the work, to just advance the federated learning techniques as well. Okay. Cool. Let's just switch gears a little bit. I will now dive a bit more deeper about how you can build federated learning apps with Flower. What are the components that you need for that? So we start off with the Flower CLI. While I say that it's written in Python, I think the easiest entry point is to use the Flower CLI, and that helps build you through, helps you build the apps that you need. Right, there are 5 key commands for the Flower CLI that can help you through this. The first one is the Flower new command. This command helps you quickly create a new Flower app from a template. It reduces a lot of boilerplate code. For example, if you want to iterate on a particular project and you just don't want to reproduce the boilerplate code, you just run Flower new, choose from one of the provided machine learning frameworks, and then you can quickly iterate on that. I will show you an example later on. The next 4 commands, which is the Flower run, log, list, and stop, helps you execute your Flower app, view the logs of your run so you can track and trace the progress of it. You can also list the statistics of all the runs that are running in the background, and also stop the actual training itself. Because the federated learning, it might take some time, same like any machine learning algorithm. So if you want to stop it for some reason, you can execute Flower stop. What's most important is these same 4 commands. You can use it both in your research code and the production code. Let me explain a little bit more what that means. Right? Flower is optimized for 2 runtime environments. Right? First runtime is what we call the simulation runtime. There you can iterate on your federated learning architecture as well as the data set, but in a simulation environment. And with the same code, you can execute it in a production. Right? By production, I mean you deploy necessary components. Let's just say different clients or hospitals or financial institutions, and then actually execute the Flower code in production. Okay. So what this means is that you can quickly move between simulation and deploy with the same set of Flower CLI commands. So you don't actually have to do any. You don't have to do any changes, significant changes to your code base in order to execute them in production. Okay. Hopefully that's sort of quite clear so far. So let's take a first look of how it looks like to run a Flower simulation on a single machine. Right. So this is very easy. As a user, you want to experiment on on a particular neural network architecture, for example, on a simple data set. The easiest way for you to get started is just to do Flower FLWR space run space and the name of the app. Okay, and for that I'll run you through the demo number 1. So I will switch screens right now, and I will walk you through that. Now let's see if I can get that to work. All right. Hopefully you can see my screen. It's my VS Code. That's pretty straightforward for everyone, I hope. My Explorer is empty. There's nothing here. I'm just in a folder here. I have also an environment set up for Austin Python demo. Okay. I've already pre-installed Flower with pip install upgrade Flower. Well, yeah, upgrade Flower. This is what I've already installed from earlier, so it's already done. So the first step for this in a simulation is to go Flower new. Hopefully you can see this. Let me know if I should, maybe I should just expand a little bit. Okay. First step you do is to run Flower new. When you run that, you are prompted with a few commands. Right. The first one is to please provide the app name. In this case, I'll just call it demo. And then the next question is please provide a Flower username. And call it Chong Shen. You can call it anything as long as I think there's no space inside. That's fine. We go Chong Shen. And now it asks you to select the machine learning framework for you to work on, right? So you can PyTorch, TensorFlow, or the other JAX MLX ones, right? So let's search. Let's select PyTorch for now. All right. For those of you who look a bit closely, you can see that the Explorer here is now populated with this file structure, right? He has a couple of things. He has a demo folder with another module called demo. He has several files, client app, server app, task, and then a couple of additional things here like gitignore, pyproject.toml, which would look rather familiar. All of these has the full code for you to actually execute Flower app in a simulation runtime out of the box, right? So how this looks like is with what I've run earlier. Since I have already installed this demo, I can just do Flower run demo, right? I'll just give it a few seconds. You can see it starting up. So this runs an actual federated learning workload for 10 clients, where 50% of the 10 clients are sampled. So you can see here, you sampled 5 clients out of 10. It's only 3 rounds. It only trains for 3 rounds, just to keep it very short. And you can see that it finishes very nicely. Okay. We can have a quick look about how we can change things here. So let's take a look at the pyproject.toml. It simply stores the configs, both for the dependencies of the app itself. In this case, we're using a PyTorch, and also some additional Flower-specific configurations, right? So in this table for FLWR, I have a few components here. So let me highlight to you what's important for this demo here. So the number of clients that participate in this federated learning is set by this value here, options.num minus supernode equals to 10. If I want to set, let's say, 500 clients, I can just change this line to 500, and I'll run the same code again, flower run demo, right? Once I do that, you should see that 500 actual clients has been created, and we have a fraction of fit value set at 50%, 0.5. So you can see 250 clients are sampled, and that means 250 models are trained and then aggregated. And this is done over 3 rounds. Right? So this is working out of the box. All right. I will also quickly show you the components of the code here, so you can see what's going on under the hood. There is in this folder structure, if I open task.py, it looks like a lot, but for those who have worked in deep learning before, you will see some very familiar classes here, right? So you have this net class, which is basically that defines your model itself, right? And then some other additional functions here, like load data, train and test, get weights and set weights, right? So train and test is something very normal for deep learning, right? It's nothing to do with federated learning at all. But what we're doing is to use the same methods that are called, the same functions that are used for deep learning, and use it in in our framework itself, right? Now in the server app, it's a very short. This is very short. Only have not that many lines. But what it effectively does is that it has a server function which accepts a number of configurations from the what we call the context, and this is taken from the PyProject.toml. It initializes the model parameters like I described earlier, and then it defines a strategy to aggregate the model weights. In this case, we use the federated averaging strategy. Now, this simply takes the average of all the model weights that's received, and then sends it back up. And then finally, it just creates this server app, and then this server app is app that gets executed on the server side, right, when it aggregates the model weights. The client app has a bit more components over here, but it more or less has the same structure in that it has a client function, which also receives a number of configurations taken from the PyProject.toml, and then it loads the data, and then it returns what we call a flower client. Now, this flower client is a special class that defines several methods that is needed to do the federated learning itself, right? So what it does is the client will do a fit, which means it actually trains a model on its own local data, and then it returns the weights from the local training itself back to the server to be aggregated. Right. I will leave it at that without diving into too much detail, and I'll switch back to my presentation now. Okay. Feel free to ask me any questions if you have any. Okay. All right, I'm just switching screens at the moment. Back to here. All right. So back to the presentation. So let's see. All right. So that was the first demo where we run it in simulation mode, right? So we simply just command line, and then we just did a flower run. Let's try and look into how we can deploy flower. Right, to deploy flower, there are 3 main components. First, you need the flower CLI, where is the entry point for the user to execute the flower model itself. Next, you need some server here, right? So this server would be the component that trains that aggregates the model, and it also receives the instructions from the flower CLI. And the third component that you need is the client, or in this case, as many clients as you need in a federation. right? So once you can set up these 3 components, you're good to go to deploy Flower. Right? So within these dash green boxes, there are a few Flower specific components. All right. In the server, you have what we call the superlink. The superlink is a long running process, and its main function is to receive instructions from the Flower CLI, and also to communicate with the supernodes, right? You push or pull messages from the supernode. The messages will contain the model parameters, some configurations, or some metrics. Okay. On the client side, the long-running process in this case are the supernodes. The supernodes is similar to superlink, right? The supernodes, the job of the supernode is to receive instructions from the superlink, and then it will retrieve the trained model from the client itself, and then sends it back to the superlink. Okay. This missing component over here are the actual apps itself, right? Remember earlier I showed you a bit of the server app and the client app. This is what these are the components that get executed within the server and the clients, right? So in this case, the superlink will speed up the server app, and the server app will, in this case, it's a short running process. In the sense that for, let's just say, for a predefined 5 rounds, the server app will only be spun up for that 5 rounds to aggregate the models. Similarly, for the client apps are spun up by the supernode, and the client apps job is to run the federated learning workload, whether it's training or run evaluation or run any query on the data set attached to the client. Okay. This architecture here is what we call the subprocess mode, simply because the superlink spins up the server app. And similarly, the supernode spins up the client app in its own subprocess. To deploy Flower in this case, you can do it in 3 steps. So the first step is to do a pip install Flower on a user's machine, like what I've done before, and from there you can just execute your command. The second step is you can do it in multiple ways, right? Here I show you one of the ways to do it, which is to start the superlink container using Docker run. Right, so just with one line Docker run -minus superlink, we have official Docker images. You can spin up a superlink on your machine, and that can just wait and receive any instructions to execute your Flower apps. And then the third step is to start the supernode containers, so as many containers as you want that is connected to a data source, and then this can be connected to the superlink itself. Okay. So this is in a very simple case, a 3-step way to deploy Flower. So let me switch to the second demo in this case, and walk you through how this looks like. Okay. I'm gonna switch screens again. Okay. Oops. Terminal. There we go. All right, we're back in the VS Code again. It's the same app. Nothing has changed. Let me just clear it. But what I'm going to do now is, instead of running in simulation mode, I'm going to run it in a deployment mode. What I've already done is I've already spun up a superlink and 5 supernodes. So all these are on standby, right? And it's just waiting for instructions. So in this PyProject.toml, I have to add just 3 lines in order to help, for the Flower CLI to send the instructions to that superlink, right? So to do that, what I need to add is a new table called flower2 federations. I will call it deploy. So deploy is the name of the federation in this case, whereas earlier I ran against the local simulation federation. So in this table, I will set the address of the superlink. It's a local superlink. So in this case, for example, 1993. And I also have root certificates because I'm running it in a secure way. So my connections between the Flower CLI and the superlink is secure. And I know where the path to the root certificates are, so I can specify it here. So, okay, let me check. Address, root certificates of CRT. Yeah, and that's it. So now in the terminal, I can run the same thing with a slight change to the command. In this case, I'll do flower run demo to run the name of the app. I will point it to the federation, which is deploy, and I will stream the logs as well, so I can see it appearing. So let's do that. So once I run that, you can see that there's a run ID that's attached to this. The Flower server app process is started. And then there are 5 supernodes that are identified. Since my fraction fit is 50%, rounded down, it samples 2 clients for training. Yeah, so this will continue to train over 3 rounds, as configured before. In this case, it will be a bit slower just because of the communications between the components are over gRPC. So there are some serialization and deserialization going on as well. Yeah, and computation.
Hello.
Yes.
Question. So do you have those 5 supernodes running in Docker containers on your local computer, or are those like somewhere else, like on the cloud or something?
Yeah. I've run them in just in the terminal at the moment. So it's just a 1-line execution. So not Docker container. That you can run it in multiple ways. You can run it using the Flower supernode command, followed by some arguments, or you can run it in Docker containers as well. Yeah.
But your 5 clients. So where are your 5 clients? They
are running on my machine at the moment.
Okay. And would you have to configure, like if they're deployed somewhere, they have different IP addresses, you'd have to configure that in your project?
You don't have to configure the IP addresses. So what you need to do is, let's just say you have one edge device, you're deploying the Flower supernode. What you need to do is to tell the Flower supernode to connect to the gRPC server that sits on the superlink. And
Okay.
That's all it needs to do.
Got it. You just need to connect it back to the server.
Yeah.
Thank you.
No worries. Okay. Yeah, I think that's it from my demo perspective. I will switch back to my slides and I will slowly wrap up. Switch back. Share this window. Okay, so that was demo number 2. It's very short and compact, but feel free to ask me any questions. Yeah.
Is there a way to configure like the whole superlink on the server side, where like how the aggregation is done? You mentioned one example where you just take the average of all the weights, but yeah, is there a way to configure that?
Yes, absolutely. Let me show my screen. Share window. So you can see my VS Code, right? So yes. So fat average is one of the many strategies that we've really bundled within Flower itself. There is you can look at all the other options that you have in terms of averaging it. These are the very I think well-established ones. So fat procs. So to use a different strategy is as simple as just changing fat average to fat procs, and now you have a different way of aggregating the server weights, aggregating the model weights from the clients.
Cool. We kind of have a sub question there. Is like, how do you average an LLM? Like, what kind of strategy would you use for an LLM based model?
Yeah, absolutely. So, so there are a few ways to answer this. So, firstly, usually when you train an LLM, you don't usually want to aggregate all of the layers. Usually, you refine like the last couple of layers, for example.
Mhm.
And I think the more recent examples, they actually just use federated averaging just to establish like a baseline. And if you look into Flower Tune, I'm going to drop something in chat. Flower Tune LLMs. If you look up Flower Tune LLM, we actually have a write-up of how we tune LLMs as well. So there is a leaderboard that we host right now for different projects, like in natural language or in coding, and you can see the participants will use different types of strategies to aggregate them. It can be federated averaging, or it can be some other types of strategy.
Okay, interesting.
Yeah. Okay. Cool. Yeah, if there are no further questions, I'll resume. But feel free to just stop me again if you want to ask more. Okay. Great. So that was the second demo. So what's next? Let's see. We recorded a short course with Deep Learning.ai with Andrew Ng. So that's our CEO, Daniel. That's our Chief Science Officer, Nick. So it's a short course, Intro to Federated Learning. Actually, so if you want to learn about how you can train LLMs in a federated way, this is actually covered in the second part of this short course as well. It's free to take. I think it takes about 4 to 6 hours to complete. So if you have some spare time, feel free to check it out as well. I think it's a very well contained short course that can help you get your hands more dirty to run Flower itself. If you are also interested to just learn a bit more about the FL with Flower, every month we have what we call the Flower Monthly. We have researchers who come in, give some talks about their work, or if you have any interesting talk that you want to give, also with the Federated Learning in mind, feel free to email me, chong.shen@flower.ai. We can work out some arrangement as well. Yeah, so the Flower platform itself has come a long way. We've gone through many iterations, almost nine versions. There are a lot of features that currently exist in the latest version of Flower. I only briefly mentioned a few of them in a demo earlier. There are a couple that I want to pick out for you here, just briefly mention so that you can keep them in mind. We have this feature about fab delivery. So what it does is the Flower app is actually bundled from the user's machine and gets sent out to the client itself. And that piece of code and that app is executed on the client side itself, right? So you don't have to actually have your code sitting on the clients or the supernodes when it's executed, but rather it's from the machine of the user. When the user executes it, that gets sent out and gets executed. We also have the isolated execution feature. So what this means is that if your Docker container, if you want to keep it very bulletproof, right? You want to keep it as slim as possible, then your superlink can be a very minimal, say, Alpine-based image. So its pure function is to receive instructions from the Flower CLI and to communicate with the supernodes. Then you run a second container, which contains a server app, and that server app will be dedicated to just aggregating the model weights. So your superlink process is completely isolated from your server app. Similarly, your supernode and client apps can be completely isolated and run in separate processes itself. We also have node authentication. What this means is that the clients are securely authenticated with the superlink. So you don't so you can't just spin up any additional supernodes and try to connect the superlink. You need to have the proper certificates to connect to it. And then you have custom message handlers. These are mechanisms that help you really tailor what you can do with the messages, right? You can, it's almost like a sort of like a middleware per se, right? You can customize how the messages gets processed before you send it to the client app, etc. So really, it's super flexible. Yeah, and that wraps it up. So our our ecosystem is very rich. We're always looking to adopt new tools if we can and support the users as much as we can. Of Flower CLIs, you can very quickly get started with Flower New and Flower Run. We're open source, so you can feel free to check us out and use it for your projects if you like. And yeah, if you have any questions, feel free to ask. I can answer them now, or even later if you want.
Chong, I promise not to ask questions, but because I'm in conflict of interest here, I'm doing things similar to what you're doing to some degree. But I must ask it because I also organize the meetup, and I want people to better understand the use cases of where this is actually really important. You kind of bypassed at the beginning, but can you take like some case, something that you cannot do something without something like Flower AI does? Because in some cases, you just cannot do things without the power that Flower AI gives them. I'm asking it because the people in Antler might get business ideas out of what you're doing and might be better users. So take some case where you actually have a restriction on the data that people will understand and then build up from there. And I won't elaborate much more, but I had to ask this so people will understand better.
Okay, no worries. Okay, I can talk about use cases. I think this would be the easiest way to explain it. So healthcare sector is very much requires federated learning, right? For example, there are several hospitals that want to collaborate to train a computer vision model for a very specific use case. But all of this data, right, is patient specific. So a lot of sensitive information. So these hospitals will never want to share their data across or centralize them for any manner to train these models. So in that case, this is where federated learning comes in. So what we do is with all our components, right, we can just deploy it in each of the hospitals. Let's just say 5 hospitals, deploy it there. There are supernodes in each hospital. And then we can host the superlink, for example. And then the data scientist can come in and then just train a computer vision model in a federated way across the images from all these hospitals. This is sort of one use case that I can share. Similarly, for financial institutions, that's also a very strict requirements. If you have banks in different location, and there's some use case. I can't go into too much details about it as well, but these banks, they do not want to share information, but they want to collectively have some form of AI being trained for some specific use cases. And this is where if you having the supernodes deployed in these institutions and you do this training, you can also be able to achieve a federated train model as well. And on the other end of the spectrum, I'll just give a third example and then I'll hand it back to the floor. A third example is there are cases where in the remote sensing industry, there are tons of data being generated at the point where the sensors are deployed, right? And it's really close to impossible to sort of centralize the model, centralize the data in order to sort of to train something meaningful. So in those cases, you really want to avoid the data movement cost itself, and so you deploy this supernodes to the clients close to the point where the data is generated, and you try and federate the model as well. So these are the sort of 3 use cases I can hopefully give some idea.
I have a question there on the last one. So like, yeah, I'm thinking like self-driving cars, right? You collect all this data, you have all these sensors going, and you can store it all. People do, but you don't know what's interesting, what's good data, what's just like, the random. And when you do this averaging of it, can you just decide like to take the top performing models, I guess, and just average on that? Like, you don't want to average on everything. Like, I bet there's a lot of techniques for it. I'm not very in the known about federated learning, but that's definitely a very interesting piece of this averaging, or maybe taking the top or investigating.
Definitely. Yeah, so it's a very good point that you raised there. I think this is where sort of MLOps sort of creep in between federated learning and MLOps, right? So where federated learning comes in is you want to omit as many outliers as possible, because outliers can be an indicator of some malicious actor, right? You have some sort of data poisoning occurring at the data source. In that perspective, there are strategies that you can implement to help you reduce or mitigate this data poisoning attacks, right? Because you want to have, you don't want your model to be trained on bad data. That's one aspect of it. From the MLOps perspective, right, there are other ways they can do to collect good quality data, right? So you have you can have some soft labeling approach, and then you only keep the data that you have high confidence for, right? Just using the probability scores to help you keep the data that you're most confident about, and then only train on the data that you on this small data set. So you actually curate the data set in your data gathering pipeline at the edge. So it's a combination of these two strategies, as well as based on a use case, that you can find the best balance of producing an accurate federated model.
Interesting. Nice.
How well does it scale? Like, how well does the approach scale once you reach a certain amount of clients and you're using this averaging method? I assume it kind of just becomes noise and they start to somewhat cancel out. I would imagine that if you go from 10,000 to 100,000 clients, maybe you'll see a large difference, but then from 100,000 to 1,000,000, maybe not. Like what kind of scales have you seen in the research projects?
Yeah, I've seen scales of a few hundred. So I know of a data set which is based on an actual image data set for a few hundred users, right? So let's just say, I think it was of the order of 500 users. Each user has a set of images. And the model that was trained, right, it was trained against this like 500 or so users, and you can see pretty good performance, right? So from a pre-trained image model, you then refine it against this data set, and the model performance is it does improve. It doesn't just decay or lose information, but it actually does improve over time. In fact, this is a work with it's the Apple Flare project. Actually, you can look it up as well. It's a data set released by Apple's on Hugging Face, and they use that for federated learning. So depending on the use case, it can scale pretty well.
I had a quick question, and I apologize if I'm misunderstanding, but are there like community hosted super links or something? So if somebody wanted to set this up to put together all these other ones to train on and create a model, is there like a way to do that? I might be misunderstanding how the super nodes connect back to a super link, but would there be, if somebody didn't want to have to set up get together and set up super nodes, they could use there's a community super link one that's set up.
Any public projects?
Publicly.
Yeah. It's a very interesting point you raise. What I can say for now is you have to stay tuned for the next couple of weeks.
Oh, okay.
So for federated learning, you said that there's like a global model and then it's trained on different devices. So is it possible to like use different mix of models for different devices, or have the same global model be used but have a different architecture to train on the devices better? Is that possible?
Oh, this is a very interesting question. Yes, I think there have been some works on that, but you need to how to say, you need to sort of like upscale or downscale your global model onto the device. There's definitely some work on that. I've seen it before. Yeah.
Oh, I think that's everything from us. Anyone else online? If not, we'll give you a little round of applause. Thank you very much for your demo.
Thank you for having me. It was great.
Oh, sorry, I just lost you on the TV because I think I turned it off. But I got you.
Right, yeah. Thanks for having me. I think it was great. I loved presenting it. Really interesting to hear what would be the possible use case that you think of as well. And communication channels are always open. Feel free to ping us on Slack or ping me directly as well. We can always discuss more.
Well, thank you. I think we're going to take like 10-15 minute intermission, and we'll bring KK up as the next speaker.